One of the things which Satoshi probably did wrong was the fact that he never defined Bitcoin protocol as a standard. He wrote just a software, and it led to multiple hard forks, unintended hard forks. The Lightning Network, which was created with an idea of being reckless, quickly innovate, iterate, experiment, even not being afraid of failing, it ended up being more ossified than Bitcoin Layer 1. If there is something that somebody needs to test, like discrete log contracts on Lightning, or another structure of channel on Lightning, you can take LNP Node and LNP library, and you can, in a very simple way, add new functionality without rewriting other parts. This year, at the beginning of this year, like 2 months ago, we completed the release of version which we called 0.10, which is expected to become the version 1. And this version finally ships everything that we believe RGB must have. The client-side validation is, I believe it is a killer, it's a blockchain killer. So that's why sometimes we are saying that RGB is a post-blockchain smart contracts.
Maxim Orlovsky is the founder of the LNP BP Standards Association and is the creator of the RGB Smart Contracts Protocol, which is based on the earlier work of client-side validation and assets on Bitcoin and Lightning, introduced by Peter Todd and Giacomo Zucco. In our conversation, we explored the importance of having standards in Bitcoin and in Lightning. We discussed what RGB is, how it works, and why it is important. And then we got into Maxim's additional work on things like LNP Node and reNostr. If you enjoyed this episode and if you learned something new from it, the best way you can show your support for the show is by sending in sats over the Lightning Network. You can use any podcasting 2.0 app to do that. There are dozens of them out there, but my favorite one to use is Fountain. Before we get into today's show, just a quick message from our sponsors. Today's show is sponsored by Voltage. Voltage is the premier provider of Bitcoin and Lightning node infrastructure. Today's show is also sponsored by Stackwork. And Stackwork is a Lightning-powered transcription tool that takes the best of AIs and humans to create better, faster, and less expensive transcripts. We'll have more from Voltage and Stackwork later in the show. Maxim, thank you for taking the time to chat with me today about all that you're working on. RGB is a topic that I've heard a lot of people discussing. A lot of people have asked me to, put an episode together on RGB and have someone come on, and I figure you're the perfect person for that. But before we get into RGB, exactly how it works and what it is, why don't you give listeners a backstory for yourself from the moment you kind of discovered Bitcoin and said, this is something interesting, to today, and all the kind of like the evolution of your understanding of Bitcoin and your experience building on Bitcoin.
Thank you very much for inviting on your show and giving this opportunity to discuss RGB. And we are really looking into making more people aware of what's going on, because RGB is a thing that doesn't produce any new tokens, has nothing to do with any companies, and it's a pure non-profit, pure cypherpunk project. And of course, it would be nice to bring the Bitcoin community attention to it. So thank you for helping doing that. Regarding myself, answering your question, I had quite a long road towards RGB. Not Bitcoin, but towards RGB. The day when I first got to know about Bitcoin was the days when I were doing banking software for fintech projects like internet banking, mobile banking, integrating large banks back in Ukraine. And it was 2014 when several people I knew from banking community, they came with this Bitcoin thing, which I didn't know before, and I was very excited. And back in those days, we have set up Bitcoin Foundation Ukraine, which started promoting Bitcoin not just inside the banking industry, but also for acceptance, public acceptance and government acceptance. So we were working with the National Bank, we were working with the government of Ukraine, bringing their attention, educating, and that was the activity of this Bitcoin Foundation Ukraine was one of the reasons why Ukraine were among the countries which first started using crypto in business. It had a lot of crypto-related projects, and even some banks were playing, and frequently National Bank were closing eyes on different things which help to proliferate the crypto exchanges and overall acceptance of the cryptocurrencies and Bitcoin those days. Of course, we made a mistake that many were making those days, which is saying that trying to promote Bitcoin by saying, well, you may not be comfortable with Bitcoin as money, but here is the blockchain thing, which is the real value of the technology. And because, well, we were sincere, at least I didn't understood those days that there is something wrong with blockchain. And it is Bitcoin which is the value, and not blockchain as a technology which can be theoretically extracted out of Bitcoin and still have some value. So that was a misconception. So I have to admit that I am one of the person who put my hand into this narrative, because we're working again with the National Bank and government. It had an impact, and I understood that it's not true, not exactly that way. It was much later, but before that, an Ethereum has appeared, as you probably remember, and that's where I was very excited seeing that Ethereum can be a base layer for much more advanced stuff than Bitcoin can do. And we started doing a project of decentralized machine learning protocol based on Ethereum. The project is still running today, but it has completely changed its shape. I will be saying a few words about that later. It's called Pandora. The original name was Pandora Box Chain, like Pandora box put into a chain of events. And we used Ethereum as a base layer for the technology. So the protocol allowed a trustless, decentralized, high-load computing, including machine learning, but it was run and made with Ethereum and EVM. And the thing that we faced in 2017 and 18 is the fact that it is impossible to scale this project. So you can run the computing, but you can't serve more than 2 or 3 clients with that solution, because Ethereum blockchain would stop. And it was the same time where when I met Giacomo Zucco. I met him back in 2017. And Giacomo Zucco was those days, and he remains a promoter of the idea that blockchain is bad. It is Bitcoin which is the value, and blockchain is the thing that makes it's a necessary for Bitcoin to exist, but it is a necessary bad thing, meaning that if there would be a way of doing Bitcoin without blockchain, it would be much better. But unfortunately, we don't know such a way. So we still have to use blockchain, which is unscalable, not very much confidential. It has a lot of drawbacks, but still we have to use it. But of course, there is no reason of taking blockchain out of Bitcoin, because you're taking the worst part of Bitcoin, which has no value outside of Bitcoin itself, and it's a nonsense. So I started understanding such concepts those days, and I also was witnessing myself the scalability problems of Ethereum. So I started looking into how to bring protocols like the machine learning protocol we were doing to Bitcoin. And Bitcoin, of course, wasn't scalable by itself at the blockchain layer, but there was a Lightning Network. So is there any way of leveraging Lightning Network capabilities to do what was promised to be possible with Ethereum, but in reality wasn't possible because of scalability problems? So can we do the same in a scalable way with Bitcoin and Lightning Network? And that was in 2019, and that was the point of time where Giacomo had this idea based on the earlier Peter taught ideas about RGB. And the RGB those days was an early prototype around the concept of let's do colored coins over Lightning in more scalable and in more efficient way than just with op returns. And my understanding of that, like I was absolutely not interested in colored coins on Lightning or whatever, or other coins those days. But I saw the potential of RGB as a technology which can be used to bring Turing-complete computing and trustless computing and complex smart contracts to Bitcoin and Lightning. The thing that I was looking for. And that's why I decided to start working on completing RGB and turning RGB into a system that can run Turing-complete smart contracts in a scalable way, in a private way, and which can be used for other projects the way like other projects use Ethereum today to build different decentralized applications and decentralized finance things, but with Bitcoin and Lightning without any additional tokens if they are not required, with Bitcoin as base layer money, with a peer-to-peer network, not using blockchain if it's possible not to use it, and so on and so forth. So in 2019, we formed a body called LNP BP Standards Association. The name came from the LNPBP meme, which was produced by Giacomo, and LNPBP meme is a word play with a TCP/IP concept. So you have these TCP/IP protocols which are making the foundation for the internet. And if we will look for analogies as Bitcoin and Lightning making the foundation for a new financial system or even a new computing platform, which is the case of RGB, we can take Lightning Network Protocol as an analogy of TCP, which is on top of IP, or Bitcoin Protocol, BP. So we have this LNP BP thing matching TCP/IP name. So that's how the name of this non-profit association has appeared. It was established in Switzerland, and since that, I'm leading the RGB development there. So that's maybe too much detailed.
No, that's great. That's perfect. So let's start with the LNP BP Standards Association. I want to first understand and give listeners a perspective. Why are standards important? What is this body meant to accomplish?
The standards are important because if you do something in a non-standard way, nobody else will understand you. Or especially, it's not that critical in the world of humans, but it's much more critical in the world of machines, because humans are much more agile, at least these days. So we can adjust somehow, we can reconstruct an information which is missing. But again, we usually do that doing a lot of mistakes and errors. But unlike human, machines need certain rules and algorithms to parse. And everything that exists in the software and hardware industry is based on standards. If you start thinking from the processors, CPUs, you would have plenty of standards like x86 architecture, then ARM architecture. It's all standards which are defining the way the hardware working, and there is a standardizing body which manages these standards. These bodies, there are multiple bodies. It's like International Standards Organization and Internet Engineering Task Force, IAEE, another standardizing body, and so on and so forth. Also, in the world of internet, everything is a standard. TCP is a standard, IP is a standard. That's where we have RFCs managed by Internet Engineering Task Force. HTTP is a standard, HTML is a standard, JavaScript, which is ECMAScript, is a standard, and these standards are managed by Web3 Consortium, by ECMA, which is another standardizing body. So if you build a protocol, which should be a networking protocol or a distributed computing protocol or smart contracting protocol, you have no other way than defining a standard way of implementing this protocol. The standards help to others to formally analyze and audit the qualities of the protocol, to do independent implementation. So standards are critical for decentralization, because if you did something and you don't explain how you can do the same thing in reproducible way, there would be no decentralization. You will end up having just a single client. And thus, if you are looking for decentralization, you have to explain how to reproduce your protocol. And the explanation how to reproduce your protocol is actually a standard. It's a definition of what standard is. Also, because working on RGB, there were multiple teams involved from different companies sharing the same interest of building a system of smart contracts on Lightning. You have to coordinate activities, and the best way how to coordinate activities is through the standardization. That's again how worldwide 3 consortium was created, W3C. It is a body which was jointly created by Microsoft, Apple, Mozilla, and other bodies who were coordinating through it in the software and browsers they were developing. So we had that feeling, me and Giacomo, because we are coming both from the academic sphere, we understood clearly that for the success of creating a new smart contracting layer, there is a need for a body which will be able to help that operation and standardization of the protocols. One of the things which Satoshi probably did wrong was the fact that he never defined Bitcoin protocol as a standard. He wrote just a software, and it led to multiple hard forks, unintended hard forks. And it is still impossible to create another Bitcoin implementation and prove that this implementation will follow the same consensus as Bitcoin Core. Why? Because there is no standard defining what Bitcoin is. And actually, Bitcoin is whatever run on Bitcoin Core. So that was a mistake. We saw it as a mistake. So we tried to not repeat the same mistake again.
I see. This is really interesting. I want to hear now the reverse argument. I hear the argument that if Bitcoin was created as a standard, there may have been some advantages coming from that. What are the disadvantages? What are the reasons why Bitcoin should not have been created as a standard? I want you to play devil's advocate here and kind of like tackle the other side of that issue.
The main disadvantage of having a standard is that usually there is a body who governs the standard, meaning that this body is itself a point of centralization, and it may introduce some changes to the standard in the future. So I don't see this as a strong counter-argument, because there is counter-arguments to these counter-arguments. Like when you define a standard is an immutable thing, always. So you say that it's ISO 1009 2001, it means that it would be never modified. The only thing that standardizing body can do is to do another standard which amends or updates the previous standard. But again, it will be a free choice of everybody to use that new standard or not to use that new standard. So it doesn't brings the previous standard out from existence. So while there is a certain centralization in the process of standardization through the standardizing body, it's still not something that is enforced upon everyone. It's an absolutely voluntary decision. So it's the same like Bitcoin Core. It's not enforced to anyone. People can fork it and use it in a different way. So I don't think that this argument is strong about this centralization. So I see the standardizing body not as a point of centralization, but as a point of coordination, which instantly loses its power the moment it tries to enforce something.
And now I want to talk about, so on Bitcoin, we started out with no standards. What about on Lightning? What was different between those two?
The Lightning started with the standards, and this set of standards called Bolt standards, like Lightning Bolt, but Bolt is also an abbreviation of, I don't actually remember, of something.
Yeah. I think it's like...
yeah, but it's like capital letters Bolt. And there is now 12 standards, potentially 13 standards, actually 11 standards with another standards coming. And so it's better than Bitcoin in this way. But however, even Bitcoin was catching up with the absence of standards, inventing the process called BIP, Bitcoin Improvement Proposals. And BIPs actually became Bitcoin standards. The point is that BIPs, they are not covering Bitcoin itself, Bitcoin consensus. So they're covering changes to Bitcoin consensus, but there is no BIP which defines how Bitcoin originally worked. So all amendments like SegWit and Taproot, they are BIP standards, amending the status quo, which is not defined. So we are taking Bitcoin, which is undefined, and we amend it in this well-defined way, which is kind of better anyway than doing some amendments randomly without any description of these amendments or discussion of these amendments. But still, it's kind of post hoc thing. The Lightning started with the standards. However, I being actually the person who are criticizing a lot the way the Lightning standards work and were created, and it's all not only my critique, it's also a result of many discussions I had with people who are working on Lightning. Many ideas came from the critics I heard from Christian Decker, and from Giacomo again, and from Peter Todd. The problem with the bolts as standards is the fact that they are kind of randomly like splitting protocol. The Lightning thing is not something one. It's not a one thing. The Lightning is a family of different interacting protocols and layers, and people even struggling to define the layers, because maybe you heard about the very well written book called Mastering Lightning Network by René Picard and Andreas Antonopoulos and others. And this, I'm also quite a good friend of René Picard, and we also had discussions about how to layer all these protocols around, and they came up with a certain layering, and if you see there is 5 or even more layers inside the Lightning Network itself. We will come back to the layer discussion probably later. But anyway, and the standards, if you put these layers, and even in the book you see the diagram, the bolts as the standards, they are random patches on top of this layering. So they don't reflect the real structure of the Lightning Network, and they don't actually help to modularize different parts of the Lightning Network in a way that would make them easily amendable and easily innovate with them. So that is one of the reasons, at least I think that, why Lightning Network takes so long to adopt all the new things. Like we've been for ages talking about channel splits, about channel factories, and they are kind of happening, but still they haven't happened over the last 3 or 4 years. Things like Lightning offers, Vault 12, or messaging in Lightning Network, like the one used by a Sphinx chat, they are being discussed to be merged as a standard for already more than 2 years. This all takes longer than the Taproot itself in Bitcoin. So the Lightning Network, which is not a consensus layer network, so it can evolve, it doesn't require to be ossified. The Lightning Network, which was created with an idea of being reckless, quickly innovate, iterate, experiment, even not being afraid of failing, it ended up being more ossified than Bitcoin Layer 1. That is the funny part. And one of the reasons for that is the way how the standards are structured and how the governance over the standards are made. So the point, coming back to the original question, why we created this association, which were helping developing the protocol, is not just an association. it's not like LNP BP Association, but LNP BP Standards Association, is because we were looking for solving this, not to repeat the problem we had in Bitcoin and we have in Lightning Network, but to do that properly the way it is done by ISO and other standard bodies to avoid problems like we discussed.
What do you think? What steps would you be taking to improve the way that Lightning standards operate? Like you mentioned that there's, it's slower than expected, and there's things that you wish were integrated already and that have not been. If you were to gather everyone working on Lightning in a room, what initiatives would you put forth to accelerate the adoption of these certain like Lightning standards and Lightning innovations?
Well, I don't think that is possible because we are too far. In there, it's not just human factor in the reality that we have both standards, which are implemented by multiple parties, which are being taught to developers, with which developers are working. So, like, you can't put the cheese paste back into the tube. So it's already there. So I don't think that there is anything can be done. So that's why we tried to do that from the very beginning when we started working on a new protocol and on a new layer to help not to get into the same situation when it is too late to change something. The other thing is that it's not just about RGB. So many parts which are not standardized in terms of Bitcoin itself, whenever it doesn't require any software or hard fork, or Lightning Network, we are also happy to standardize as LNP-BP standard to help to address the future compatibility issues and to boost the development of the Lightning Network. So we are ourselves working on the Lightning Network implementation called LNP and LNP Node, which is experimental, of course, but it's our attempt how you can make at least the software and architecture of the node open for new protocols and new experiments and faster innovations. All these innovations and new protocols, like integration of RGB into the Lightning Network or an alternative way how you can use Taproot or create a multi-peer channels, we're also standardizing there, proposing as standards there. So we're kind of trying to launch the parallel process of faster innovation with the Lightning Network for those who are not satisfied with the speed how the Lightning Network evolves through the Bolt standards.
So your Lightning implementation, LNP node, this is supposed to be iterating faster than the existing implementations can today? Is it like I'm trying to understand how?
Not iterating faster, but allowing a simpler experiment, trying new things in a simpler way, in a faster way. So if there is something that somebody needs to test, like discrete log contracts on Lightning, or another structure of channel on Lightning, you can take LNP node and LNP library, and you can, in a very simple way, add new functionality without rewriting other parts. Because the consequence of the way how the Bolt standards work was the architecture which all modern Lightning nodes has. Is that if you need to change something, you end up with a rewriting a lot of different parts of the node itself. And that's what make the progress and innovation so slow, because it's not just a standard Bolt standard you need to update. It is like when we were trying to integrate RGB back in the days where we were using pay-to-contract commitments, which is not the case of today, but when we were doing that, we came out to conclusion that we have to write like up to the third of the whole code base of each of the existing Lightning nodes in order to get one thing working, because the architecture is not modular enough and is not abstracted enough to allow changes. Basically, both Bolt standards and Lightning nodes are one-case software built for dual payment channels with a very specific and strict set of protocols. That's why Taproot or PTLC or other things come into to Lightning takes so long because they have to rewrite a lot of the code base to do that. So the LNP node was created deliberately with allowing a composability, like with the category theory and all that stuff, that when you need to add one feature, you don't need to touch or rewrite existing feature set. So you can compose these features all together, and as a side effect, you can have a channel factory which can construct channels of different constructions. You can compose one channels with another, so everything is modular, everything is interoperable, and everything is composable. So it's the LNP node is a small implementation, meaning that we don't have a capacity to pretend to be a full Lightning node, mainstream Lightning node, having all the modern features in terms of funds management and everything. But what we can do is actually a node for developers and those who'd like to play with the new things in Lightning, where they can quickly and easily add new features without having a need to rewrite a lot of code base or doing a fork of C Lightning or LND and then maintaining that fork.
I see. That makes a lot of sense. Let's get into RGB. I want to shift gears a little bit here. And maybe to start off, you can just give people a high-level explainer. I think RGB, the term people are familiar with, but I don't know that. I think there's going to be some listeners who are not familiar with the intricacies of how it all works. So can you just give a high-level explainer of what RGB is?
RGB is a smart contracts, Turing-complete smart contracts for Bitcoin and most importantly, Lightning network. So you may think about RGB as a thing that allows to do everything that was promised to be possible with Ethereum or other smart contract solutions post Bitcoin, but wasn't possible because of scalability issues, centralization issues. Like you can do advanced smart contracts, but there is just one or several nodes around the world who are able to run the nodes to do the stuff, like Solana. So it's like it still fails for fulfillment of the promise. The idea is that with RGB, you are finally able to have Turing complete smart contracts and do what was promised by other systems, but with a Bitcoin and Lightning network, not requiring invention of a new blockchain, introduction of new consensus protocol, introduction of new layer one coins like Ether and many of others. With a Bitcoin proof of work, with a Bitcoin blockchain, with a Lightning network on top, Turing complete smart contracts, not requiring any Ether for gas fees, wrapping Bitcoin into Ethereum, or doing all that crazy and unnecessary stuff. So the RGB allows Bitcoin finance applications and decentralized applications, dApps, on top of Bitcoin and Lightning network without ever touching everything related to Bitcoin, to Ethereum or other non-Bitcoin blockchains. And we call this Bitcoin finance, like it's a DeFi, but made with Bitcoin and Lightning.
I hope you're enjoying the show so far. Just a quick message from our sponsor, Voltage. Voltage empowers engineers to integrate Bitcoin and Lightning network payments into their business stack with an enterprise-grade experience. The team at Voltage is building the complete tool set so that you can do more than simply spin up nodes, but also understand and interpret your node's data. Their new product, Surge, gives engineers the capability to quickly solve problems and optimize operations. With node insights and visibility through time series data, you get dynamic and complex insights never available before. You can get complete control with insanely fast onboarding, advanced client-side encryption, and zero management infrastructure, making backups, networking, and upgrades simple. Get a free 7-day trial today at voltage.cloud. So now I have a couple questions. First is, why is it that this iteration, RGB, can succeed where other Turing complete smart contract platforms, in your view, have failed or have not been able to scale? What makes it that RGB is going to be different from something like Ethereum? And then as a second kind of follow-up question, I think there's a segment of the Bitcoin population that says we don't even need smart contracts. We don't need the Turing complete smart contracts. So there's a follow-up there of, is this even necessary?
Let me start with the first part. Well, the first thing that RGB is different from Ethereum is that it is built on Bitcoin and not on a new blockchain. So we don't create a new token, we don't do an ICO to launch a smart contracting system, we're not creating a new proof of stake consensus. So we are already in much better position. Our money is Bitcoin and nothing else. So this is the first real advantage. The second real advantage is that we are reusing Lightning Network, meaning that we have the scalability not just because of RGB. There is some things which allows RGB to be more scalable, but because we inherit scalability from the Lightning Network. So that's what Ethereum doesn't have. We are not solving the scalability problem per se. We already have a solution of scalability problem, which is Lightning Network. So that is the second thing that allows us to do something that wasn't possible with Ethereum or other blockchains. The third thing how RGB is different is the fact that we are using a thing called client-side validation. And this is very, very important and strong concept. And it actually answers partially the second question. So let me probably elaborate on it for some time. The client-side validation is, I believe it is a killer, it's a blockchain killer. So that's why sometimes we are saying that RGB is a post-blockchain smart contracts. Yes, they are using layer 1 Bitcoin blockchain as of today, but theoretically in the future they may evolve into a thing that doesn't require blockchain as it is understood today. So the client-side validation says very simple thing. The first one is that everything that is important regarding the contracts, let's put smart contracts aside and start talking about just a contracts. I think nobody would be against the fact that people do need contracts. I would like to make a contract with you. I would like to employ somebody. I would like to pay somebody. I'm a company. I'm doing a company. I'm attracting investments. I do need a contract. Even if we live in hyper-Bitcoinized world, there would be a contract.
I agree, yeah.
And if we have a contract, we need probably a digital contracts, right? And if we have a digital contracts, what we probably do is like we write the contract and then we sign it digitally with a digital signature. We don't need blockchain for that, right?
Right.
That's a client-side validation. That's what RGB is doing. It's just a system of how you can manage that type of contracts and operations with these contracts. And now that's where the scalability and confidentiality and privacy is coming from. Because if I'm doing a contract with you, digital contract, we are not talking about smart contract, digital contract. We do sign a document together. I do sign a document, let's say, and I'm sending it to you. I'm not using blockchain for that, right? I'm just sending it. Email, via messenger, a piece of paper, a QR code. Like I can use any means. I'm abstracted from the means of information transfer. The same RGB. RGB can send the client-side validated data. The first thing that it can't use for that is blockchain. And it's not using blockchain for storing any data at all. That is a huge scalability win. You don't need to put something into blockchain. And RGB can send it via Lightning Network, via Nostr, via Telegram, via email, via Morse codes, through the radio waves, and any means that you can invent. And when you receive this contract signed by me, you decode it, of course. And what you are doing, are you going to Infura infrastructure in Asia to ask it, is it valid? Ethereum Infura infrastructure today? Or are you contacting Bitcoin Core to check its validity? No, you are not doing that. What you do is that you just verify the signature on the contract. So there is two peers involved in the contract, and there is nobody in the world who knows or need to witness the interaction between these two peers. And this is a huge scalability gain, because there is no informationally centralized point of failure. The blockchain is a decentralized system, but it is informationally centralized, meaning that all the information exist within one distributed database. Yes, it is distributed database blockchain, but still each node has the whole information in the whole world copied to their local hard drive. Meaning that you can't have a large blocks, otherwise people wouldn't be able to run nodes. But with RGB and client-side validation, you are not copying the information of the whole world. You are not verifying the information of the whole world contract operations. You just do your part, which you are interested in, and you incentivize to do this verification because it's contracts you are participating. There is no additional incentivization in form of tokens or Ethereum or gas that is required. You participate in contracts. You certainly participating because you assume that it has value for you, and because it has a value for you, you do the verification of these contracts on your local device, not verifying the rest of what the rest of the world does. That's why RGB is scalable, and that's why RGB with the client-side validation is extremely different from things which are done with Ethereum. You may think about the RGB contract as a shard. It's a kind of sharded protocol from day one, the thing that Ethereum was thinking about for ages. But these shards are natural. It's like a shards with the contract paper, pieces of paper you have at your house. They are all sharded by design. And the next thing that ultimately client-side validation gives to us is the extreme confidentiality privacy. Why? Because you are not uploading your contracts and your data and your state and anything into any public network. You are not publishing that into blockchain, which has to be validated by all the nodes. It's only me and you in the whole world who knows about the existence of this contract. And this concept exists for ages. It's called bearer rights or bearer contracts, meaning that you own the stuff that you have. And the initial stock exchange in Netherlands and Britain was a bearer rights stock exchange. And even now, in some jurisdictions like British Virgin Islands, a share certificate is a bearer share certificate, meaning that there is no registry where it's registered. You have just a piece of paper in your safe at your house, and that is your contract. So that is a client-side validation. Client-side validation is a bearer right system. So, and it's very private. As you know, like BVI shareholding, nobody can see that unless people will voluntarily disclose that. The same with RGB. So you get scalability, you get privacy just for nothing because you are not storing something in blockchain, because you don't need blockchain. That is the client-side validation. And the only part of the story where Bitcoin blockchain does appear is the part of the story when you change something, you operate with a contract, you're building a history of these operations. For instance, you may amend the contract, or you may have some assets which you need to transfer under the terms of the contract, or I did a work and you confirm that I indeed did the work, so I'm using that to ask you for a payment and you do the payment for me. So these are operations under the contract, and this history need to be provably unique, meaning that there is no alternative history exist. For instance, let's say that there is a couple and they wait for a child, and they go into the doctor and asking what would be the gender or what would be the sex of our child. Would it be a girl or a boy? Or let's say in political correct way, what would be the chromosome set? It would be XX or XY or some other mutation. And the doctor does the diagnosis and says, oh, it would be a boy, it would be XY chromosomes. But in his journal, doctor writes two records. One says that it would be a boy, and the other that would be a girl. And when the couple comes back and say, well, wait, you said that it would be a boy, but it's actually a girl, he says, no, you remember in the wrong way. Here is the record. And he takes the second record. So this is analogy of double spending. Like in Bitcoin, you may have double spending. Here you may have a double commitment. Like you can commit to two different things. And that's what can't be solved with things like open timestamps or blockchain commitments. It can't be solved because you can create two alternative histories, two alternative commitments, and then nobody in the world would be able to prove that there is no alternative that exists. So if a doctor put those commitments to his prognosis of would it be a boy or girl to open timestamps, he can still create two different timestamps proving that it's girl, he said that it was a girl, and proving that he said that it was a boy. And that's where RGB solved that differently from the open timestamps. And it does this solution with a primitive called single-use seals. Single-use seals is like open timestamps in Power 2. And actually, both of the things were created by Peter Todd. So he invented initially the timestamping with the blockchain, and then he understood this limitation of the timestamp, so he created a second cryptographic primitive, which we called single-use seals. And what single-use seals you allow to you is to prove the uniqueness of certain commitment. So when you said that it's a boy, you can't anymore commit that it's a girl. And that's where Bitcoin blockchain is required. So you leverage Bitcoin blockchain, but you don't put the actual data and the actual promise of a boy or a girl into a blockchain. You do a very different thing. If I don't know, should I go into details trying to explain that not a technical level, but like some common level, how it actually works? How do you think, should I?
Sure.
Yeah. So
I think that's useful.
Getting back to our example with the doctor, when a couple came to the doctor, the doctor runs a log, a record, a journal, and he uses Bitcoin blockchain to run this journal. And the doctor says that initially, I do control this Bitcoin transaction output. You know that like people probably think about Bitcoin as an addresses and Bitcoins on the addresses. Bitcoins do not exist on the addresses in the blockchain. Bitcoin exists in transaction outputs, and the address is actually a descriptor of a set of transaction outputs. So the atomic unit is the transaction output. In some wallets, it's called UTXO, unspent transaction output, or coins. Like in an Electrum wallet, if you go, you will have a tab called coins, and there you would have multiple entries for the same address, for the same descriptor of the output. So we are talking about Bitcoin transaction outputs, and Bitcoin transaction outputs are owned by people who has the private keys to that addresses, meaning that they are able to spend this output. And when the doctor receives the license, he says that he proves that I do own this transaction output. Here is the signature with my private key that I do own this output. Only one. And then each time the doctor make a prognosis, he spends that output with a certain transaction. And inside that transaction, he puts a commitment to the prognosis that he made. And because Bitcoin transaction output can be spent only once, there might be only single commitment that exists. So it's basically open timestamps created in a very specific predefined place. That's what single-use seals is. And with that, you create a provably unique history. And that by itself is a smart contract to a certain degree, even without any Turing completeness. And that's how RGB works. So you have a client-side data, and you create commitments to the state of the contract, which you put into Bitcoin transaction. But you put it into Bitcoin transaction not by using blockchain space, but instead you're doing quite advanced thing, much more advanced than Ordinals or BRC are doing, where they are putting data right into Bitcoin blockchain, bloating it, and creating a huge privacy leaks and problems for everybody. But no, here you are not doing that. You're just encoding that in some taproot tree, and then it just modifies the address. But at the end of the day, you don't have additional storage usage on blockchain. More than that, anybody looking into the transaction wouldn't even see that it's anyhow Bitcoin or RGB related, because there is nothing in this transaction that makes no information is stored. When I say that you commit to the state of the contract, it means that you hash the data of the contract, and the hash is the function that goes one way. You can't go other way around. You can't detect what are the data actually, what is the state of the smart contract actually is. And nobody has this smart contract than you. So that's how RGB is working. And because RGB works with Bitcoin transactions, not blockchain per se, but with the Bitcoin transactions, it automatically works with the Lightning Network. And on top of Lightning Network, because Bitcoin transactions exist in Lightning Network as well. So the final source of truth is still goes down to blockchain, because Lightning is secure only because it can publish the transactions on chain and get them mined. But the same construction actually allows RGB to be on top of the Lightning Network and scale with the Lightning Network, having all the data client side. So I hope that was understandable explanation.
That was very helpful. I now have a question about the types of contracts and smart contracts that you expect people to be using on RGB. What does that look like? Is it going to be any different from what we've seen on Ethereum or any of the other kind of like applications you mentioned, ordinals and BRC20s bloating Bitcoin's chain? Are there what applications do you envision being used on
I'm quite
RGB?
sure people will do all the forms of scams that they just can't invent and imagine, of course. This is the first thing they do. Why they do this? Because they are prohibited from doing that in the real world. That's why the scam has become the main use case for blockchain projects, because people can't gamble because of the regulations. People can't invest because of regulations in many places. So the first thing they are doing is usually something scamming. The same will happen with RGB. There is no doubt. Even without RGB, we have this craziness of ordinals and inscriptions, whatever their name is, which is 99.999% scam. So it's not the guilt of RGB. It's not that RGB would be the reason of this scams. Like, it's not the knife which kills people. It's a hand and a human which does that. The same RGBs. It's a tool, and unfortunately, it will be used for bad things as well as good things. Hopefully. But using this opportunity to answer the second question, to explain people why we need smart contracts in Bitcoin at all, I would say that, as I demonstrated, there is no chance that there would be a world where the contracts wouldn't be used. And the way RGB works, it makes these contracts digital and at least provable. In many cases, it requires certain form of arbitrage, like you define a third-party arbiter, because when the contract is broken, there is no way how you can enforce it. So you need some other means, and there might be a centralization. But even with this centralization, having a digital form of smart contracts which is scalable and confidential, based on bearer rights instruments, that is a huge win for the future. So it is basically a legal system. It creates a foundation to build a legal system in a way that doesn't have a centralization in terms of the registries, in terms of the regulators, the same way like Bitcoin lets you to avoid centralization in terms of central banks. But even more than that, I do believe that financial contracts are important, because if you're thinking about real economy and real use cases where, for instance, I'm a merchant selling my goods for Bitcoins, or even not Bitcoins, whatever, I'm selling my goods, and even if Bitcoin will not be volatile, still the price of the source materials I'm using in producing my good may be volatile. Maybe there is a fire or COVID or something happens. And for instance, I'm a tailor, I'm doing a shirts, and the textile got double in price next month. So I have to insure against that risk. And the way I do insurance is I'm doing a future contract. And the future contract is a financial contract. And especially in the world where we exist with a bit hyper-Bitcoinization, I need to be able to do a future contract against Bitcoin. Otherwise, I wouldn't be able to operate as a merchant. So for all those Bitcoiners who think that they are smart and they think that changing money would change anything and they don't need a finance, I wish them to live in the world where there would be just money and finance. Well, that's a caveman world. Many of them are happy with the K-main world, but sorry, it's not for me, and probably many other people wouldn't agree to go back into caves. And not to go into caves, you need a real economy, and real economy requires finance, and finance is futures, options, stocks, exchanges, and other things. If you are doing a project, you would probably issue share certificates, and you would like to attract investors. Of course, none of the smart contracts, neither on Ethereum nor on Bitcoin, would be able to solve the problem of the centralization of trust with the issuer of the shares. So if you buy shares of Apple, you trust Apple that it will behave well. But it's not the problem that we need to solve at all, the fact of the centralization of the issuer of certain forms of financial contracts. What we need to solve is to restore bearer right financial contracts and censorship-resistant secondary markets. Like if I buy Apple shares, there should be no party that may prevent me from selling it, including Apple itself. That is what censorship-resistant secondary market is. And without smart contracts, a system like RGB, this is not achievable. So that's the explanation why we need smart contracts on Bitcoin.
Makes sense. Now, I want to spend some time talking about the current state of RGB. Where is it at today? What are the requirements from a technical standpoint to get this to production? Is anything required on Bitcoin? Does anything need to change on Bitcoin? Anything need to change on Lightning in order for RGB to become production grade kind of technology?
Mm-hmm. So RGB being in the development since 2017, probably. Like I don't exactly remember the day when it starts. I've been involved with that since 2019, so it's mostly 4 years, and it went through quite a lot of things. The reason why we were preventing any usage of RGB is because we were not happy with the protocol, and we didn't want it to be used before it has all the properties that we need. So this year, at the beginning of this year, like 2 months ago, we completed the release of version which we called 0.10, which is expected to become the version 1. And this version finally ships everything that we believe RGB must have. It's a lot of functionality, including a dedicated virtual machine, Turing complete smart contracts, ability to, it is based on Taproot, it is able to work with the Lightning Network, not requiring any modification to the core Lightning properties and protocols. It requires some amendments, which are very tiny and simple to implement, because with this version, because we already have 2 implementations of RGB for Lightning Network. The second implementation was created by just recently in March and April by Bitfinex team working on RGB, and they made this RGB implementation with LDK, existing Lightning Development Kit by Spiral. And the first implementation was the implementation based on LNP Node, which I was talking before. And we also found that it's possible today to implement RGB as a plugin for C Lightning, and there would be certainly work that would happen with that. So we would have 2 mainstream and another experimental implementation of RGB on Lightning Network. And are people able to use it today? No, they are not, because to use the protocol is quite a low-level thing. And to use it, the people who would be issuing or transacting, they would need a software working with the protocol. Wallets, exchanges, and other tools. And that is the stage we are at. At least 5 or 4, 6 even teams independently working on creating software, including Bitfinex, including my own company, including American companies like Diba, who are doing the web browser-based extension for managing Bitcoins, RGB assets, and NFTs on Bitcoin, including Japanese projects, game developers. So we are in the phase where we do create wallets which will work with RGB. We do work with exchanges which will be using RGB. We work with the first issuers who will be issuing assets, important assets on RGB. And this is the bootstrap phase. So the protocol is ready. We are building the ecosystem of software which is required for people to start to use RGB. So I think in the second half of the year, we will start seeing first initial adoption and first public projects and assets and smart contracts appearing on RGB. The wallets which support RGB are MyCitadel, which is developed by my company, and this was the first one. Later, we got Block's Bitfinex team, and they made Iris wallet. And I already mentioned Tiba with their BitMask wallet extension, which is kind of the same as MetaMask for Ethereum. BitMask is targeting the same niche for Bitcoin. And there are other projects which I don't even fully aware of all of them. So that's the stage we are at.
Right. What are you looking for in the next kind of couple months from, feedback from this v0.10 release to get to version 1? What are you kind of like hoping to get from, having put out that v.0.10 release?
Well, we first of all need to get software engineers to integrate it into wallets and exchanges and make sure that they have everything they need. Then we need first assets being issued and not stolen by others. So we need a certain proof that the system does the job as expected. There would be also an audit which will be examining the existing standards and code base. And one of the things we achieved is where we are able to clearly separate the consensus level of RGB from all application level and make consensus level as portable, as small as possible, such that it would be easier, and as well as documented as possible, it would be easier to audit it. And if everything of this would be seamless and happy, there would be a happy end, that's where the version first would appear.
Okay. I have another question about the kind of structure and architecture of RGB, where it fits in the broader kind of like Bitcoin and Lightning ecosystem. I had a discussion a couple of weeks ago with Lisa Neiget, and we were talking about layers in Bitcoin. And I had kind of mentioned I lose the analogy of layers after we get past layer 1 and layer 2. It starts to not make sense for me, and I think she kind of agreed with that. What is your view on what RGB represents? Is this like layering number system relevant? Is RGB a layer 3? Where does it all fit in?
Well, I think the question of layering is more a question of memes than the question of actual technology and engineering, because the technology is much more complex. I already said that Lightning itself is built of multiple layers.
Right.
And if you try to put RGB into this, Bitcoin itself actually has several layers, to be frank. Like it's a meme saying that there is a layer 1. Well, Bitcoin is composed of the consensus protocol layer, which is proof of work, and which can work even without the existing Bitcoin blockchain. You can merge mine into it, for instance. There is a layer of blocks, blockchain itself, which uses the layer of consensus protocol. And it has its own consensus rules, additional to the proof of work consensus rules. There is layer of sidechains different, which is again, is it layer 1, layer 2, layer 1.5, layer 1 plus I, like should we go complex numbers, then with the Lightning Network and RGB we need to go quaternions and octonions, probably transfinite numbers. So like it's just, it doesn't make, the layering doesn't make a lot of sense for me. And there is also a mempool which people start calling layer 0, which is even more strange because at least layer 1 has a consensus, and layer 2 using the layer 1 consensus. Mempool doesn't have a consensus, it has some policies, and there is no state inside the mempool, which should be the same for all the nodes. Like, I think it's more the way people like to say it, it's the best way. Like if they would like to see mempool layer 0, bit blockchain layer 1, Lightning layer 2, RGB layer 3, let it be. So like it doesn't change anything in the reality. RGB works on top of Lightning, but on the other side, Lightning node has to be aware of RGB assets and contracts existing in the channel. So it's like sticking into the Lightning itself. So like it splits the Lightning into two layers. I don't know. Is it on top of Lightning? In certain sense, yes. Is it underneath the Lightning? In certain sense, yes. And the only layering I can imagine, which can be consistent, is that there is a layer of Bitcoin consensus, which is the layer 1. And this layer 1 is Bitcoin transactions mined on chain. If this transaction exists outside of the chain, but it is still deterministically mineable, like in Lightning channels, it's a layer 2. And there is something that exists outside of Bitcoin transaction, but is committed into Bitcoin transaction, like client-side validation and RGB, it can be considered a layer 3. In these terms, yes, there is a Bitcoin blockchain layer 1, Lightning Network, which can be seen as layer 2, and RGB as an example of layer 3 application.
I see. So maybe is it useful to, instead of sticking with these numbers, is it maybe useful to say that RGB requires to some degree the Bitcoin blockchain, and to some degree it is it benefits from having the Lightning network to kind of plug into. Is that kind of roughly correct?
I would say slightly differently. RGB requires Bitcoin transactions to exist, and the rules how these Bitcoin transactions are made final, like Lightning Network on top of Bitcoin consensus or pure Bitcoin consensus.
I see.
So it doesn't require blockchain per se, it requires Bitcoin transactions, let's say it this way.
I hope you're enjoying the show so far. Just a quick message from our sponsor, Stackwork. Stackwork is a Lightning-powered platform for generating high-quality transcripts of all your audio or video content. They combine AI engines and hundreds of human workers all over the world who are paid over the Lightning Network to assemble these transcripts. And that's what lets Stackwork create better, faster, and less expensive transcripts. To see the results for yourself, you can check out my personal website where I host transcripts for all my podcast episodes. If you want to learn more about Stackwork, visit stackwork.com. That is STAK work.com. Now, I want to spend a little bit of time talking about Nostr, because I know you're working on stuff there as well. And you wrote a recent Twitter post. It was I don't know what to call them now. Twitter posts are longer than 280 characters. It was almost a blog post. But I
wrote it in Nostr as well, originally. I just copied it to Twitter.
Yeah. I mean, well, so this post, it was explaining your views kind of on under-designed protocols and thoughtfully designed protocols and different strategies in protocol adoption and creation. Can you give people a high-level overview of your views on the Nostr protocol as it pertains to this blog post you wrote?
Yeah, yes. The reason I started looking into this direction, well, there is several reasons. The first one is that I'm interested in decentralized protocols, and that's my professional area where I have to be aware, and I'm looking into what's there, what else is there. And the second, that the Nostr is getting quite a good adoption and interest from the community, and RGB needs data propagation layer. As I described, you need somehow to send this client-side validated data between the users. And while we are working on dedicated protocols for that, based on Lightning Network, I understand that if Nostr has a huge adoption and people are already using it, it would be nice to let people use their existing infrastructure like relay nodes, and have multiple transports for RGB such that users can decide which one they use. And that's how I ended up analyzing Nostr protocol. I think, I don't know, was you asking how we are planning to use Nostr and what we're planning to do with Nostr, or are you asking actually what our opinion about Nostr.
Let's start with your opinion on Nostr.
My opinion on Nostr is it's hard to put it shortly. There is no resume. It's good for one thing. It's not that good for other things. And there are certain pitfalls I see. Like, I don't want to blame anybody because it's absolutely unimaginably hard to design decentralized protocols. And it's even harder, probably impossible, to design them without flaws. And I'm quite sure there would be flaws in RGB, and people would be 5 years from now would be saying, "Oh, Maxim wasn't that smart. He actually made all these mistakes, and we spent years solving them." Like, the same is said about Satoshi, like why he did that or that or that. Well, it's hard to design things like that. So I'm not criticizing Nostr in any way, but the reality for me is that the pitfalls that exist in the Nostr protocol allow things like DOS attacks. We haven't seen them, but I see a number of factors which may affect the network quite severely. And I think that would start happening the more adoption will go, the more it would happen. There would be, of course, countermeasures, and there could be countermeasures, but these countermeasures would be taken on the level of individual relays, which would eventually lead to network decoherence, meaning that other different relays would have different policies, and it would be harder for the software to implement the same rules independent of relays. And the absence of the same rules would lead that certain forms of contracts will randomly disappear. So when you will be looking through your feed, you will see that there is a post, but the image is missed, or the repost, but the original post is not there anymore. So you would have this decoherence effect of that. So DOS attacks, then policies. The policies are not standardized across the node, then the decoherence, and finally a scalability problem. This is a severe, well, for my opinion, a severe danger for the network growth phase. And I think all of these problems are addressable. And the final problem, the scalability problem, also includes the problem of the speed, because even today, clients, especially mobile clients, they do two things. First, they struggle to parse a lot of JSON data because it's long to parse them, ending with a slow user interface. But even worse, they don't verify signatures. You know why? Because if they would verify signatures, the curve that is used by Nostr, which is Bitcoin curve, the SEC P256K1, is extremely slow with signature verification, and it burns battery. So if the client would verify signatures of the messages, your phone will die instantly. So that's also part of the scalability problem. And this results in the fact that clients trust relays on the signatures, which is kind of the same SPV problem we had in Bitcoin. Like, I can post today, I can run a relay, I can promote it, and I can spread the fake news through this relay, saying that, let's say, let's say some presidential candidate like Kennedy, who joined Nostr quite recently, posted something, but I would put a fake signature, which is not a valid signature. But because mobile clients do not verify that, well, I will be spreading fake news, and it will work. So these problems are quite dramatic for me. So Nostr working today, Nostr getting popular today, and the next stage would be much more critical for Nostr future because he would face scalability, DOS, decoherence, and fake news problems. And the signature mechanism, which were devoted to solve these problems and prevent these problems, is not working because everybody is starting using SPV trusting relays. And that is addressable, and that's what we are trying to address with this initiative we call reNostr. A revision of the Nostr foundations and basics, which would exist in parallel with the Nostr protocol, such that relays would be able to implement both of the protocols. The reNostr is backwards compatible with the Nostr, so basically any reNostr message you can present as a Nostr messaging, but and partially otherwise. So I hope that clients it would take months, if not years, and we're gathering partners who are interested in supporting us in these activities. But we believe that combination of Bitcoin, Nostr, RGB, and Lightning is extremely powerful combination. That's why we are spending time and effort on this initiative. And that's probably an answer to both of the questions.
Yeah. So I want to hear more about reNostr, exactly how it works and what makes it different from Nostr as we know it today.
There are several features which make it really different. The first one is that it uses binary encoding instead of JSON. It makes it fast, it makes it deterministic, it prevents many DOS attack vectors as well as security attack vectors. Because it's really hard to parse JSON in a secure way, not like there could be code injections attacks and others. It is really slow to parse JSON comparing to binary data, like up to 25 times slower, like 25 times, like it's 2 orders of magnitude. And it is also, there is no rules how long the messages could be, which is a target for DOS attacks, and that the coherence which may result from these attacks. So by solving with a binary encoding, we're solving the problem of DOS attacks because every part of the message has a strict rules how long it could be, and not longer than that. Meaning that it's harder to DOS attack, and even if a DOS attack happens, there are already policy rules which are in place, which are coherent across the network. The binary encoding is the first important thing. The second important thing that we would like to change the signatures from SecP to Edwards curve at 25519, which are many orders of magnitude faster, which can run on mobile without draining the battery, and which are the standard which is used in all identity systems. GPG, PGP. It is used in SSH. It is used in TLS, SSL, everywhere. So if you have your own PGP key, you can use it for Nostr. I think it's a reasonable assumption to do. That is the second change. The third change is that we will be using end-to-end encryption. And that would allow much higher level of security and confidentiality, and also make Nostr be able to run on top of the mixed networks, including Tor network and NIM project, if you heard about that, because Tor have the scalability issues these days as well. And finally, is that we are making a dedicated TCP-based protocol. So first, today clients operate with the WebSockets. And while WebSockets is really easy to use, they have several drawbacks because the number of clients per relay is really limited, very highly limited. And the load on the relays is very huge. So we would like to upgrade the WebSocket version of protocol to a mutex, to a mix of WebSockets and HTTP. So whenever you need to post something, you use HTTP. When you need to subscribe for something, you use WebSockets. And also provide a TCP, stateless TCP protocol that will allow servers to work. For instance, if you're on a mobile or a desktop client, you don't need WebSockets at all. You can use a normal TCP layer. So these are all changes which are part. So altogether, this is what reNostr is. And we are not just doing the protocol, the client, the company, Pandora Prime, we do have a product I already mentioned, MyCitadel wallet, which is Bitcoin wallet and RGB wallet and eventually Lightning wallet. And we plan to use Nostr inside this wallet to help people to synchronize the state of the wallet descriptors and annotations across the devices, or companies and organizations using Bitcoin to set up multi-sigs and do PSBTs and signature processes through the Nostr relays. And, as I already told, exchange of the RGB data, contracts, and consignments, which are required for payments in RGB.
Now, right now, Nostr is, I think, primarily used by people as a social media tool. It a lot of the clients are Twitter-like, and but we're seeing some that kind of differ. We've seen marketplaces, we've seen long-form blog posts. There's a few other types of clients being developed for different types of notes. What do you see as the most popular Nostr use cases moving forward?
My opinion, probably wrong, because I'm a technical person, a low-level person. So my use case probably is much different from the use case of usual people and the mass market. But my use case, which I loved in Nostr, is that it's about self-hosting. It's about self-hosting data. What Bitcoin does for money, what RGB does for legal system and finance, Nostr does for data. And these three are really closely coupled together. And I want to buy a home personal server. Well, I have, but if I'm a user, from my perspective, want to buy a box, put it at your home, and be able to synchronize all accounts and all different applications on different mobile desktop devices through this home node, not through the Google Cloud, not through the Apple iCloud, not through Dropbox, but through this box. And while I can do that for Bitcoin blockchain running Bitcoin Core on that home box, or Lightning node running Lightning node, I can't do that for that data for now. Today, it's really hard to do that. And I would like that all applications use the API that allows them to sync and store the data not in their cloud, but on this box. And Nostr, for me, is that API. And the social media is one of the edge cases of this larger use case.
Mm-hmm. I really like the way you framed that just there, where you said, Bitcoin is money, RGB is, legal and financial contracts, and Nostr is data. When you combine those three together, let's like think out, a decade out when we have a mature ecosystem surrounding these three protocols. Is there anything missing?
Yes.
There? Like, what is missing beyond those three? Intelligence?
Yeah, artificial intelligence.
All right. What's the tool that we will be using for artificial intelligence a decade out?
I hope the same home box, as I told, with empowered with additional processors which are capable of machine learning. And I'm actually an advisor in the project which works on the idea of making processors out of neural tissue called Tiamat Labs, which I think it's a very good thing because human brain, not just human brain, but any brain, the neural tissue is much better than any silicon-based processors. If you think about that, the heat production by the brain is so small and the power consumption is so small comparing to its computational capabilities, it exists for much longer because it can self-repair than any CPU. Try to use hammer slightly against your head, nothing would happen, slightly. But try to do the same force to the CPU, it will be dead and never recover. And many other things. And it runs actual intelligence, hopefully, and not emulation. And that's why I think that construction of processors from the neural tissue is the future. But even without that, you can have dedicated neural processors in home boxes today. The whole point is that it would be able to do complex things. And that's why I started this meeting with my backstory, and I was telling about this Pandora project and Prometheus protocol we did for distributed machine learning. So at the end of the day, all these components will be in place. We have a data layer with the Nostr, money, legal, smart contracts with RGB. We can run a Prometheus as decentralized intelligence, as a network of decentralized intelligence where you can actually upload your consciousness and exist there without the risk that somebody will censor you or disconnect you.
We've gone way into the science fiction rabbit hole here. This is incredible. So I want to make sure I have this correct here. Your proposal here is to use human neural tissue as a processor for artificial intelligence. Is that kind of correct?
Well, it wouldn't be artificial that much anymore,
I know. Yeah, it would be
intelligence.
real intelligence. It'd be human tissue,
Yeah,
right?
it's not a proposal. It's actually a startup that does that. There is a few others as well.
Huh.
So that would become true eventually, I think.
Very interesting. This is like, I think the AI stuff is kind of, it's still something that I'm trying to wrap my head around. And I feel like I have less of a grip on that than I do of any of the other Bitcoin, Lightning, Nostr stuff, which I still am trying to wrap my head around. So it feels like it's just another level of complexity and another level of unknowns and uncertainties. Do you have any good frameworks for thinking about the effect that AI may have
Yes,
on the world?
yes.
All right, let's
The
hear it.
framework is very simple. It's called self-sovereignty. You just need
Self-servant?
to self-sovereignty.
Oh, self-sovereignty.
Yeah, you need to think about the problem, any problem, in context of yourself and that self-sovereignty. So AI is just a tool, as RGB, as many others. And as you can use a knife to kill somebody or Bitcoin to sponsor terrorism, you, of course, for sure, would be able to use AI to do a lot of nasty things. So blockchain and AI can be used and potentially will be used. At least there are for sure attempts to use them, blockchain and AI, to build a digital concentration camps by governments. This is the fact. And it will continue to happen. At the same time, there are tools to build sovereignty for the individuals seeking it. So it's a tool, and it's the question of how we will use that tool. And the things we are doing is to build tools for people to build sovereignty, which can't be used for building digital concentration camps. If you self-host at your home with your box, if you run Bitcoin Core node or node, if you run Nostr Relay, if you have your processor at your home, if you're using decentralized networks which are censorship resistant when you need it, for instance, you wouldn't ever have enough computing power to use supercomputing applications, but you would like to use them directly, not through paying taxes to a United States government running supercomputers predicting weather for you. You would like to have a direct access to that. So, and you can't do that with a self-hosting. There, where you need decentralized networks which can operate trustlessly and censorship resistant. That's where you need RGB contracts to be able to construct computing in this network with a game theory that would enable that trustlessness. So the self-sovereignty will use the same tools, just as setup will differ. And as I said, we have non-profit doing the protocols, but we also have a for-profit company, Pandora Prime, which tries to create tools with a proper setup enabling that self-sovereignty.
This is wild. Really fascinating discussion. Thank you so much for taking the time today. I learned a ton. I may have to go through this conversation again myself just to absorb everything. It was just loaded with great insight. So I appreciate you taking the time. Where can people
Thank
go
you for
to learn more?
inviting and letting doing that.
Of course. Where can people go to learn more about you and RGB?
About RGB, there is a website called rgb.tech. It's the introductory website which has guidelines how to download tools, issue simple contracts. As I said, there would be a wallet providing high-level user interface, so today it's quite a low level, but it's a good place to start. About myself, I don't know. Should I advise people to learn about me, because I don't want to be a brand guy of the RGB or of anything. I don't want to repeat the stories of Buterin or anything else. So I think, but if somebody interested, they can always find by my surname media, where I have a personal blog and website, so it can be found by Googling.
Got it. Well, thank you again for the time, and I hope we can do it again soon.
Thank you. Thank you.
Hope you guys enjoyed the show. Just a quick note, I am recording this outro for Maxim's episode at the exact same time as I'm releasing Shazan's episode, so I do not have any visibility into the sats or comments or anything you guys sent in this week. I will have that in the next episode, so keep on sending in sats if you enjoy these episodes. Can't wait to see your comments from this week, and talk to you soon.